Thank you, Colin. Yes, I am going to talk about the navigation as something that other people like non-drivers can also use properly. I'm Anna Basiri. I'm a professor of geospatial data science at the University of Glasgow and UKRI Future Leader Fellow. I also have the role of editor-in-chief of Journal of Navigation, so I may refer some part of the talk to the journal's paper, so that's a bit of self-promotion in some sense, but I hope you will forgive us. This is Roll Institute of Navigation event in some sense. So the reason that I wanted to talk about non-drivers navigation is basically because the whole discipline of navigation started from maritime and aviation, and some of the discipline that have got some interest and motivation to develop navigation as a part of their service. And later on, towards the last few decades, we realized that maybe actually pedestrian wants to use that with the popularity of our mobile phone that allows us to track ourselves better. And we just tailored those navigation services to the need of human on their foot. And then that becomes a bit of an issue because there are some sort of differences between human and non-drivers and cars and pilots and captains of vessels. So I hope by the end of this talk we appreciate that these differences between drivers and non-drivers, that include bicycle, wheelchair users, pedestrian and scooter users, make the whole system of navigation slightly different, and we need to consider that. And so perhaps we can design some sort of service that is good for them and not just tailored to their need. So what is the difference between drivers and non-drivers that makes our life very difficult? There are so many. I list some of them and tell you how they affect the navigation that we use. The first one is the fact that drivers can be kind of limited to the network of roads and directions of network of roads. As pedestrian, we don't have that much of limitation. We can go even through the buildings and find our destination. We can cross grasslands and get to our destination. And this is not really embedded in any of the routing service. For example, if you go to Google Map, I actually encourage you to do that maybe after this talk, and find two origin and destination, just put 2 points within a park, you will still see that Google Map navigate you through the road or the ways that exist, even though you can actually cross grassland, and you're allowed to do that. The reason for that is almost all the routing service are actually designed based on graph theory and being on a network of road or streets or so. That is a bit of issue. We can go inside the building, and that's completely new sort of area to cars or airplanes or vessels or so. And the whole notion of going inside the building is making our life very, very different from the drivers. We move a bit slower, and that's very different. So we are actually aware of our environment, not just aware of our environment, we are very vulnerable to the change in the environment. For example, if it is a rainy day, we are going to change our route because we don't want to get wet if we don't have umbrella. But for car, that doesn't really matter. You see that, for example, in the picture, that just a bit of surface condition make the life of whoever, like a bicycle or wheelchair user, very difficult because they cannot really pass from that pavement. But for car, that's not the major situation. So we are moving in a slower direction, slower speed. We are more vulnerable to the environment. And there are some personal factors that we have in our mind when we choose the route that we want to take. The other element of difference that we have is, as I said, as a human being, we are more vulnerable to the threat, or at least the perception of safety is important to us. So even when there is a shortest path, because we feel that's not safe, because during the night time that may not be the best path for us. And we can go, as I said, inside the building where GPS is not available. And by GPS, I mean anything that is globally available for free. This is a very unique sort of characteristic for any GNSS positioning technology that is globally available for free. It's very privacy preserving, and that's amazing. But we don't have it for indoor, so you may get lost and don't find the room or gate in the airport that you actually want to go, just because there isn't that much of positioning technology that is available in the same sense that GPS. We have Wi-Fi and other thing, but it's not as accurate as, for example, 5 meter or 10 meter or so. So these are the changes that we see, and we are hoping that with considering them, both navigation, but also the design of the city would be slightly different. Because if you look at how we design a city, I'm not an architect, but if you look at a map, the first thing that you see is road. Even when designers and planners want to design, they consider road as a really important part of the city when they design it. But to be honest, most of our time, 85% or 80% of our time, is spent inside the buildings, or pedestrians are actually the users of the city in many, many ways. And so maybe considering them as a kind of reason to design something and provide a service based on their need is quite important. So I'm hoping that based on the differences that I just described, we can come up with some solution. And in the next few slides, I'm going to talk about some of the things that could be done, or at least there's a potential to explore them, and we can actually have a better navigation for non-drivers. And by non-drivers, I'm talking about all the categories of pedestrian, bicycle, wheelchair, kids, and anyone who is not using cars. So navigation by itself can have like 4 main components. The first thing is we find origin and destination, the place that we are at the moment, or we want to start our journey, and the destination is a place that we want to actually get there. So the first sort of technology, if we say, or the resource that help us to understand where is the origin and where is the destination is map. I will talk about how maps are not very inclusive and are not really designed for the use of people like you and I. When we know the origin and destination, the next step is finding the best route from the origin to the destination. So there are some routing algorithms. I briefly mentioned what are the problem for them, but I will go through the main ways of finding the best path. When we find the best route to take, then we need to follow the route, like turn by turn, go to each point and then follow and get to the destination. And for that, we need some tracking, and for that, we need some positioning technologies in some ways, either as a kind of technology that help us or just ourselves seeing it on a map. And at the end, it's not at the end, it's along with the positioning, we need to have some communication to get the navigational instruction. So there are 4 steps. It's not necessarily following each other. Sometimes it happens at the same time. You are being rerouted, or the following and positioning and providing navigational instruction are at the same time. But at the end, there are 4 stages. And I'm going to talk about how we can actually we can have more inclusive maps, positioning technologies, and navigational instructions. So the thing that I couldn't even call it a kind of way of interaction between cars, it is a bit scary. And that is the reason that I want to say this is great for cars and any autonomous cars and anything that actually moves around, except pedestrian. And you see some people actually show this as a kind of glorious ultimate goal, that we want to have some sort of efficient navigation for these sort of cars, and this is perfect. But you see, human being is actually being missed here. And no matter how efficient is in terms of the synchronicity and the obstacle avoidance and the technology that happens within the cars and the lorries and so on, it's not safe, at least it's not perceived to be safe for the human being. So there are millions of cars passing, but there is not even a good human getting to the other side of the road within the time that we are actually seeing this. So I'm going through the elements and tell you what is basically wrong in that. So first of all, let me start with the map for non-drivers. If you look at the history of mapping and cartography, there are some sort of way of looking at it. Most of them are north up. So some people argue that, okay, that's because even the whole mapping system started in Europe. So people in Australia should not have north up because for them, the other direction should be there. So it by nature is not very inclusive. But more importantly, who decide what sort of feature should go on a map and what feature should not go on a map? But this is a very conscious decision. We can't map everything because that's by nature, we are losing the whole notion of mapping. But we decide very deliberately to remove some of the features. For example, sometimes we just map roads and we ignore, for example, the bicycle pavement lane. And that means they're not a part of our priorities. Some of my colleagues at UCL try to map the areas that are actually good for social distancing. And that was basically the first map that actually considered the width of the pavement really in London, which is a bit surprising because, if we are promoting active travel, that means we should consider that. And, that hasn't been done, which is, in some ways an amazing initiative, but a bit suspiciously too late to have this. And even at the time that we talk about, for example, crowdsourcing mapping and people can go and add any feature that they want. So there isn't any authoritative decision that, okay, this shouldn't be on the map and this should be. There is still a bit of problem because there are some minority people who, at least stereotypically, we say they're not good at reading maps, and their perception of mapping is very different. For example, there is a really interesting study showing that even on crowdsourcing application like OpenStreetMap, where anyone on the planet can go and map the building and road and so on, there are some of the features that are being missed, like nurseries and kindergarten and something that is related to childcare, just because most of people who are comfortable with going on a computer and add a feature where, like men, and traditionally they're not responsible for, childcare sort of thing, which is a bit brutal, but the brutality comes even higher. But when you know that when those women actually decided to make those features as a kind of tag, as a kind of attribute on the map, it was rejected just because there aren't enough number of women in the decision-making process to just say that, oh, childcare can have different categories. So nursery is not the same as primary school. So yeah, they basically rejected that. So by definition, some of the map do not have the features that we want to have. And that is a bit of issue, again, coming from the way that we map things. And there are some other argument that, 2D map, a two-dimensional map are not really perfect for our understanding of cities and learning about the environment. So now our technology are a bit more advanced, so we can actually have 3D maps. So why not we switch to that? Should it be based on human location? So we look at the way that we actually see the features, or should it be from iBird view, so egocentric versus other ways of presenting the map? So there are loads of arguments about even how we actually do the cartography and show the map. So that's just a bit of a flavor of how even the simplest thing like mapping, which is really basic and it has been there for many, many years, could be exclusive and make our navigation is slightly more difficult just because it was started from maritime and aviation sort of discipline. So I mentioned about the routing side. As I said, we can move in any direction. We can go through the buildings. We can cross grasslands and park. And these aren't something within the routing service as we expect. So what I call them that freedom of movement of non-drivers. So I really encourage you to test any of the mapping, any of navigation service that you have. I test the most widely used one, like Google Map, OpenStreetMap, and Bing Map, but try the other one as well. As soon as you pick 2 points in a grassland that you can actually walk and get to the destination, it still projects you to the road or to the way that exists on the map. So like the pedestrian way or those sort of things. This become a bit of an issue because, even if you put the destination within a lake, it still gets you to the nearest point. The picture in middle is actually the good way of showing that you should actually cross a railway, which is not allowed, and you get to your destination, which is slightly different from the actual destination, but you can't really swim to get to that. So this is a bit of an issue. And there is more to be done in this area because, we are not limited to the network of roads. Of course, navigation based on graph is really easy, and mathematically there are some ways to optimize that, but this is not really the most advanced way of providing a path to a pedestrian. The other thing is, most of the time, the shortest path is not really the best path for us. Sometimes we just want to explore the area. We want to go through the roofed area because it is rainy. Sometimes we actually want to go to the area that is less polluted. Unlike cars, pedestrian are not, the cost of travel is not just the time or petrol. For us, the cost of travel might be our lives, and the safest path could be the best path that we actually want to take. And these, not all of them are not really a part of the navigation service that we can get. And there are some work towards that. I must say that there are very good, recently especially, there are some work towards making, for example, the nicest way or for example, the cleanest way to pick, but still it's not there. And if you look at the human history, we've been on the planet for millions of years, and now over the last few years we just realized that actually people may not want to get through the shortest path because the purpose of the travel is not really getting to their work, for example, or so, and that would be a bit of a problem. And for some of the users, like wheelchair users and bicycle users, even if they want to get to the shortest path, there are some other factors in addition to distance that they are very interested and perhaps even vulnerable to. For example, surface condition is very important to them. So just distance doesn't mean that they can actually take that. So there is a slope of the area that they are taking, and if it is above certain degrees, they cannot really take it very well. And or for example, even a bit of one step might be completely difficult for them to take and continue their road. And you should remember that for some of the people on wheelchair, changing their route just because there is a car parked on pavement and blocked their whole path might be very difficult to deal with because they need to completely change their way. And there is a study showing that in London, 50% of wheelchair users actually change their way every day. So it's a bit annoying that 1 out of 2 actually change their way even on a daily basis because somebody parked over a pavement. And these dynamic change is not a problem for cars. because you can easily avoid, because there is a very wide lane for cars. But for wheelchair user, there is a very narrow pavement, and if there is a bin or a car parked there, for them that's a proper obstacle to avoid, and that's completely different sort of way. So how we can actually deal with the finding path in an open area like a park. So as you see, it is not possible to project everything on a graph, or it is possible, but it's not really human-centric. So one of the things that we did, we looked at building a graph on top of the polygon. For example, in this case, we can actually connect every single node that exists, and then create a graph on top of each graph, and then try to actually find the best path based on the criteria that consider the important criteria for the pathfinding. So one of the things we did, we had a survey. So we tracked some of people either on wheelchair or with those buggies to see how they actually choose their path at different time of the day, and we asked them why and what was the purpose of travel. So if it was, for example, getting to school, then that was very difficult to change their path because they couldn't really waste their time. But if it was just exploring the park and having a dog walking, that was very, very different purpose. So we can find the correct path. And the good part is when you understand what are the important factors for each participant group based on the purpose of their travel, you can actually provide a better service. So we actually designed a service that considered the slope of the road, surface condition, and so on. And in the last two figure, you see that this is what we proposed as the best path, and this is what exactly they took as the best path, which is very different from the other three. I don't know if you see my cursor. So the first three are the one that comes from Google Map, OpenStreetMap, and Bing Map. And the last two figures are the actual path that they take and the one that we considered the factors that they that we found as an important factor. So the other difference between drivers and non-drivers was the lower speed of movement. That means, first of all, we understand environment a bit better than car because they are moving very fast. So even understanding and appreciation of the environment is a bit different. And so we are also a bit more vulnerable to the changes in the environment, as I said, for example, surface condition and so on. One of the studies that we did is understanding how people actually perceive 3D maps versus 2D maps, because, as I said, people move slightly slower, and so they potentially see the other building around them, and that might be useful for their navigation or maybe distraction to their navigation. So we wanted to see how they are performing. So one of our master students, Minu, designed a virtual reality environment and provided the 2D map and 3D map to different group of people. And at the end, she asked, okay, can you recognize these features? Some of them were on the road, some of them were just random picture. And also she asked them to get to the destination that she designed. It was very surprising to me that women perform way better than men in 3D environments. And the whole stereotype that says women can't read map was just untrue. Because, and I would say we've been given just wrong maps. If we had been given 3D maps, we would have been, very, very great navigators, perhaps. And, the stereotype would be completely disappeared. They could recognize more feature, more landmark, and they got lost much fewer than men, which is a bit surprising. So this is the area in Olympic Park, Queen Elizabeth Olympic Park in London. And, the good part is when you see a 3D environment, even the role of language in navigational instruction loses its importance. For example, sometimes when we go to another country, you can't really ask other people where is that point and so on. And if you use your Google map, if you have that, then that's fantastic. But still, you need to know the language that your Google map talks. And you know, sometimes it is just in English, or you know, some certain languages if you don't adapt it. But when you see the features on the map, you're more likely to find it, and adjustment between the 3D environment that we actually see, the real world that we see, into 2D map is something that, you know, our brain needs to do, like a projection, and that is basically kind of removed. So you see a 3D environment and you see a 3D map, so your self-localization is much easier. So that's another thing. We also looked at, you know, how people actually see the navigation, and there are some big differences in how much surface condition is important, for example, for bicycle and wheelchair user and pedestrian, or the length of journey, or other thing. But there is really no difference between age and gender. These aren't the same for 2D maps. In 2D maps, there is a gender gap. There is younger people perceive something a bit better than older people. So these are kind of showing that, okay, if you want to provide a better understanding of the city, or you want a more successful navigation service, maybe you need to consider at least other options of mapping and projection. The other bit is that is not really in the current navigation. Well, it is coming up, but it hadn't been on the navigation services, is the communication very well. You know, again, going back to aviation and maritime, you don't see that much of need to communicate in different way. Multimodality is not really the top priority. But for pedestrian, that's actually very important. For example, if I go to a new city, I don't want to get into my phone all the time to just make sure that I get to my destination. I actually want to visit the city. So a turn-by-turn navigational instruction maybe is not the best, because first of all, I need to know in 200 yards I should turn right, and if there is another turning point, I may get confused. But if I see a building on my phone, and I see a building that actually I need to turn when I see that, then it's much easier. Or there are some haptic navigation. For example, there is a vibration on my phone as soon as I need to turn right, and if it is 2, that means turn left, and as long as it doesn't vibrate, that means I should go straight ahead. So that means other ways of navigation, or again, video or audio navigation, you don't want to be distracted and your, for example, your music stops because in 200 yards you need to turn left or so. You want to just make it a bit embedded in your activity. So maybe I've seen some work that turn down the music on the side that you need to turn, for example, left. So your speaker on the left side, turn it down so you know that you go. And that's actually good, because you don't need to just look at your phone or just listen to your phone when you go to a new environment. Or this is one of the navigation services that we developed when I was in Ireland in Maynooth University. And at that time, you know, back in 2012, like 8-9 years ago, instead of just saying in 200 yards turn left, we try to show the figure of the building that they need to go through, and so on. And we thought in that way, we are going to provide a bit more human-like navigational instructions. And that's quite important. We also see a kind of new gamification way of talking, and, you know, making sure that everybody have fun when they get to their destination, and that's quite important. But the point that I wanted to say about the navigational instruction, the fourth component that I wanted to say, is you need to follow the instruction completely, and that means you need to have a very good positioning technology. Otherwise, there is a mismatch between your instructions that is communicated and your current position. And that's really the most confusing bit. So we know that as a human being, we can go inside the building, and that's one of the most challenging environment for the for the positioning. We can also go to what we call urban canyon. That means there are very high-rise buildings that block your signal of GPS, and so it's really difficult. So there are so many work. Still, this is ongoing, and I cannot say this is the solution, but it seems that there are some work on multi-sensor positioning. There are some work on quantum navigation that try to make sure that based on the models that we have and the quantum technology that we have, we still not too far away from our actual point that is calculated as our position. But none of them are really perfect, and there is always a kind of argument against and for of the different technology. Of course, you can have a camera and all the time match it with, for example, a street view and see if you have the same location that you should have. But camera means you basically can potentially record other people's faces, and it's not very privacy preserving. If you want to have some Wi-Fi signal to get through to your destination when you're inside the building, then it is great, but still there is a point that in terms of accuracy, that's not still perfect. To be honest, there are so many work, and we even looked into all the positioning technology that exist really and possibly could be used. And I can tell that there is no GPS-like technology, even with all the critiques around, even GPS, okay, that's not really perfect, but there is no globally available privacy-preserving technology that can give us our location within an acceptable level of accuracy for free or very cheap. And that's the problem. And there are so many research going on this. So one of the things is our cheap new Bluetooth energy that actually can potentially help us to understand where you are, but it is very sensitive. So it is cheap, but it is too sensitive. So even if you open one of those doors or somebody just passed through this corridor, you will see that the signal is getting attenuated and your position is completely out of the actual point. But one of the clever things is, and we are working on that, to be honest, for a very long time. We are trying to understand, okay, the positioning will be deteriorated as soon as somebody comes in or the door is open. But that means we can understand something about the environment. So for pedestrian, that's still very useful information. So if we know that somebody has passed through this building, that's useful because in terms of occupancy modeling, we know that somebody is in there. So I may feel safer because there is somebody in this corridor, or because I know the door is open, so I can turn off the light because somebody has gone out of the door, or some sort of information is available in terms of the surrounding environment of the signal. So this is some of the things that can help mapping sites. So maybe positioning is not perfect, but we can actually improve the mapping. And because it is not based on somebody decide what should be in this map or shouldn't be, it is basically only data driven. It is a little more dynamic than it should be. And for pedestrian and wheelchair user, I think that would be very useful because you know that there is, for example, an obstacle there because your signal is not the same as it should be. So maybe we can find another route for the pedestrian or the wheelchair user because there is potentially some obstacle in this corridor. So I'm just trying to show that we tested with different people in this room, in this corridor, and we can actually identify the number of people or if the aircon is working or not. So if you're vulnerable to the weather condition without even knowing what is going on, without knowing your exact position, we know that, okay, in this side of the building, because it doesn't match with the actual received signal strength that we expected, we know that the aircon is on, or there are two people in this corridor or so. So it is kind of useful, but it is bad for another purpose, which is, I would say, is still a potential way of looking at it. And you know, in terms of mapping, that's very, very good. The other thing that I would like to say is when we don't have GPS signal, that's terrible, because that means we are in urban canyon, but we can even estimate the height of the building based on the blockage of the signal if we find the pattern. And that obviously means we have a better understanding of, for example, how much of a sky you get, or is it supposed to be safe, or you know, how many people are around you because they block the signal around you, or loads of other things, which is quite interesting. So I just wanted to say that when we don't have positioning inside the building or in urban canyon, that's terrible for positioning purpose, but it is also possible to create the map in a kind of more dynamic way. So I just wanted to conclude and say that, well, navigation has got several components like maps, positioning technology, navigational instructions, and routing, and all of them basically designed for pilots and captains on vessels, and even for autonomous cars and drones. We are basically missing the actual users, which are human. And I don't blame our navigation community for this. This is the way that any discipline grow. If you look at AI, for example, that we talk about it quite a lot, now we realize that, oh, we shouldn't just rely on data. We should keep the human in the loop. And, you know, any discipline comes like that. We start with just how it works, and then we look into how actually effective it works. So in our phone, we just test it and see if actually we can talk over it. But later on, we get to the point that we consider, for example, battery consumption, or, you know, other things. We need to consider now human as the center of our design of the cities. That's very important, but also as a center of our navigational instructions and mapping services, and produce the map that are good for everybody. Maybe that means we need to produce different type of maps for children that might be just 3D because they are into games and video games and so on. For elderly, might be that means that the font should be much bigger, and you know, we consider different type of features. But that means that is tailored to their purpose, and one single solution is not fit for all. And hopefully, we consider the inclusivity in the design of any service that we have. And by that, I just wanted to thank our funding bodies and partner that helped us to do these research.